Next is simplex method. So when there are more than two variables, graphical method is difficult. When there are more than two decision variables in the system, in the problem, then graphical method is difficult. Then simplex method gives best solution. So what is simplex method? Simplex method is developed by one scientist named Simplex. So here we need to follow few rules. So similar to objective function, constraint and non-restricted equations. First is set up objective function. Second, set up the constraint equations. Third is set up non-equality constraints. Fourth, this is different from the graphical. Conversion of inequalities, inequality constraints into equality constraints. So if we have less than or equal to, make it equal to by adding or subtracting some value. What is that value we discuss? Before that, we need to keep the problem in standard form before proceeding to simplex method. In standard form, problem can be either maximization or minimization. So first rule, objective function can be either maximization or minimization. Second rule, all the constraints are equations. All the constraints has to be equations. Instead of inequalities, you need to have equality. The constant value which is in right hand side of each constraint each constraint has to be positive always. Third one, all the decision variables has to be greater than 0. All the decision variables has to be greater than or equal to 0. This is about standard form. Example, zmax, convert zmax equal to 2x plus y subject to 2x plus y equal to minus 10, 3x plus y greater than or equal to 6, x plus y less than or equal to 8, x comma y greater than or equal to 0. So convert this into standard form. So standard form converting. Standard form is first objective function. You can write maximization whatever it is, whatever he has given, it is subject to. All constraint positive right hand side values has to be positive. So multiply with positive negative value. Minus 2 minus x minus y equal to 10. Next all constraints has to be equality sign. So 3x plus y, it is less than or equal to greater than or equal to constraint. If it is greater than means that is bigger, subtract some value. So that subtraction value s1 is called surplus variable. And if it is less than or equal to sin x plus y, if less than means it has less values, less value. So that's why add some value. That is called slack variable. X comma y greater than or equal to 0. So s1 is to for greater than or equal to sign you need to add, s2 is for less than or equal to sign equation. Slack variable. Slack is negligible amount of quantity is added to the less than or equal to sign constraint to convert it into equality constraint is called slack variable. Surplus variable. Negligible amount of is removed or subtracted from the constraint value such that to convert greater than or equal to constraint to equality constraint. Equality constraint. So these are the few basic steps. And regarding whether to add surplus or slack is that also depends upon for we have added the slack or surplus variable. What is the coefficient of those variables? The coefficient of slack and surplus variables is 0 in objective function. Z max equal to 3x plus 2y plus 0 s1 plus 0 s2. S1 and S2 are slack and surplus variable. Artificial variable. Artificial variable, it does not have any significance in the simplex method, but it is added to the greater than or equal to constraint to solve simplex problem easily. So 2x plus 3y greater than or equal to 12, then you can add it as 2x plus 3y sub minus s1 plus m plus a is the artificial variable equal to 0. S1 is surplus variable, a equal to artificial variable. The coefficients in objective function objective function is m or minus m plus or minus m to the artificial variable in maximization minus m in maximization and plus m in plus m in maximization minus m in maximization and plus m in minimization problem. Suppose in the above problem z max equal to 4x plus 7y, then you can add it as z max equal to 4x plus 7y plus 0 s1 maximization minus m a, that is a modified objective function after introducing slack and artificial variable. This is about the prerequisites to know to proceed to the simplex method. Then the procedure of simplex method also little bit different compared to the normal graphical method. We solve one simple problem, then you can understand the simplex method. Next, simplex procedure. Simplex procedure. Z max equal to 24x plus 48y, subject to x plus 2y is less than or equal to 48, 2x plus y less than or equal to 60, x comma y greater than or equal to 0. So this is problem where we have two variables, but this can be solved by graphical method. But why I am explaining with simplex method? It is simple problem which you can understand fundamental things. If I take complex 4 variables, 3 variables, then complexity increases. So once you understand simple problem, then you can go ahead with complex problem. So first one is, after writing that, converting into equalities. First step. Step 1. Convert unequal constraints to equality constraints. That is the first step. So after converting x plus 2y plus, we have to less than or equal to variable constraint, add slack variable 41. This is also less than or equal to constraint, add slack, another slack variable 60. Objective function now will change, z max equal to 24x plus 48y plus 0s1 plus 0s2. So the objective function will change after adding the slack variables. So then write in table form. This is easy method to proceed. These are all objective function here, variables. What are the variables in objective function? And here is a initial solution s1 and s2. What you need to do is, initially, to get initial solution, substitute x equal to 0, y equal to 0. Then the value you will get is, initial basic solution is obtained after substituting x equal to 0 and y equal to 0. Then calculate s1 and s2. So what we have done, we kept x equal to 0, y equal to 0. We got s1 and s2 are initial basic solutions. s1 equal to 48, s2 equal to 60, but that is not our required solution. So start improving the solution. So give this as a cj row. Cj means coefficients. These are the coefficients of the objective function. 0 these 0 0 are coefficients of slack variables in the objective function. And zj, zj means nothing but multiplication of the coefficient values. So zj value, the value you will get is multiply x and y coefficients of corresponding constraint with the s1 coefficients. So here 0 and 1, multiply this 0 1 plus 0 2, you will get 0 overall. 0 2 again, next this 0 and 2 below y, again 0. So whatever you do with 0, you will get zeros. Then calculate next, actually we can do here only cj minus zj. If cj minus zj is all negative values, then you can stop the solution. If there is any positive value, then you can improve the solution. So here positive value is there, so higher positive value you can enter the variable. So y is having higher positive value, enter y into the solution, and which variable is coming out. So this is called this is called entering vector. So this variable is entering, and the it is also called entering vector. Y is entering into the solution, and you shall divide b naught by minimum ratio. Calculate minimum ratio is calculated by b naught by entering vector value. So 48 by 2 24, 60 by 1 60. So out of this, whichever is minimum is a leaving vector. So minimum is s1. s1 leaves out of the solution. s1 will go out of the solution. It's called leaving vector, and y is entering vector. So after uh, doing this step, next enter the y into the solution. Y coefficient of y is 48, s2 0, and so again no, calculate the divide the leaving vector row with entire by the corresponding, this is value, right? This is a leaving vector, so correspondingly this is called cross sectional value, pivot element or pivot value. Divide entire row by that pivot value. So 1 by 2 1, 1 by 2 0, again you'll get here b naught is 24. So next, to get these values of row s2, we have to do multiply the pivot value. So whatever the value is already existing in the earlier place, 2 minus corresponding value in the leaving vector 1 into 1 by 2. So 2 minus 1 into 1 by 2 is nothing but 3 by 2. Similarly here 0 minus 1 into 0 minus 2 into, here it is 1 second, 1 minus 2 into 1 by 2 0. Next it is Earlier table it was 0, 0 minus 1 into 1 by 2, minus 1 by 2. It is earlier table 1, 1 minus 2 into 1 by 2, 0. Sorry, 1, 1. So next is 36. So again we calculate the entering and see this Cj minus, sorry, Zj values. Zj is multiply this with 48 by 24 and 48, 24, 0. Calculate Cj minus Zj and all values you will get is 0, 0, minus 24, 0. So all are less than equal to 0. So now optimal solution is reached. So optimal solution is x s1 equal to 0 and y equal to 24 is the optimal solution. Substitute that optimal solution in Zmax, you will get optimal value. So optimal value is, so x is not there in solution, so x is equal 0. So 24 g into x 0 plus 48 into y 20 plus 0 into s1 is nothing but 0 plus something. So the value is 1152. So for finally optimal solution we have reached. This is for maximization. For minimization, you need to Cj minus Z0 has to be always less than greater than or equal to 0. Then the optimization is reached. So practice few problems on this. Then you can understand the procedure of simplex method. It's very easy only. The next is primal dual. So when the problem is having more variables or difficult to solve in using simplex method or some, we have to convert them into dual problem. For every primal problem there is dual problem. There exists dual problem. It is a primal, if primal is maximization problem, if primal is maximization problem, maximization is objective function, maximization problem, then dual is minimization problem. So you need to change, flip the things. If primal contains less than or equal to constraint, convert them into greater than or equal to constraint in dual. So if simply everything, objective function and constraints. So we do one problem, then we can understand. So the primal and dual relation in the solution is, so this is dual and this is primal. Primal, if the optimal solution exists, then for dual also it is optimal solution possible. Infeasible solution never. Unbounded never. If dual is optimal, then primal also optimal. So if primal is infeasible, then dual is also infeasible or unbounded. Anything can possible. So if primal is unbounded, then dual is infeasible. Dual won't be never unbounded. So this is suppose sometimes they give in question the primal has optimal solution of this, or primal solution is unbounded. What will be the dual solution? They will give options as optimal, unbounded, infeasible. So answer is infeasible. So if you know the relation between this, then we can solve the problem. If there are m variables and n constraints in primal, if there are m variables and n constraints in primal, then the dual will have n variables and m constraints. If there are if there is less than or equal to sign in primal constraint, it becomes greater than or equal to sign in dual. Vice versa. If there is greater than or equal to sign in primal constraint, then it becomes less than or equal to sign in dual. The coefficients of the objective function, the coefficients of the objective function, functions of x and y of object in objective function, coefficients of x and y and so on variables in objective function will become constants for constraints in dual. So these are the points which we need to remember while converting primal and dual. So we do one gate question. So based on that you can understand the primal dual relationship. So this is one of the important easy to solve the gate questions. Question number 14, page number 106. Gate 2008. The question is the dual for the LP primal problem. is, so the dual for the LP primal. So LP primal he has given, so maximize 4x plus 6y subject to 3x plus 2y less than or equal to 6, 2x plus 3y less than or equal to 6, x comma y greater than or equal to 0. This is primal. So if you want to convert this to dual, maximization will convert into minimization. So the coefficients, constants will become coefficients of objective function 6x plus 6y, and this the matrix of the objective function variables will transpose. So 3x plus 2y, the 2x plus 3y, anyway they are symmetrical, so A transpose equal to A, greater than will become less than will become greater than 4, so less than again become greater than, a constant of y will become second variable, second constraint constant, coefficient of the y variable in objective function will become this unrestricted constraints will be same. So if you look at the solution, so minimize 6x plus 6y, so here he has taken u and v, you can take u and v also, I have taken x and y only. So the solution for this is which satisfies 6x plus cy. So yeah, 6 both are only a and b, so out of a and b which one is the answer. Next, check another constraints. It has to be minimization problem, but in B he has given maximization, so answer is A. Simple. 2 marks if you know the conversion of maximization to, sorry, primal to dual. Next problem. Question number 32, page number 108, gate 2003. A manufacturer produces two types of products 1 and 2 at production levels of x1 and x2 respectively. The profit is given by 2x plus 2x1 plus 5x2. So profit means always maximizing profit, right? So maximize 2x1 plus 5x2, and constraints subject to two constraints x1 plus 3x2 less than or equal to 40, 3x1 plus x2 less than or equal to 24. So draw the graph x1 x2. So before plotting that, convert these equations into intercept form. X1 by 40 plus x2 by 40 by 3 is less than or equal to 1. Similarly, x1 by 8 plus x2 by 24 less than or equal to 1. So x1 value varies from 8 to 24. So 8, 24. Y1 values varies from maybe 40 by 3 to 24. X1 value varies from 8 to 40. Okay, then draw the lines. This is equation 1, this is equation 2. So by draw those equations on the xy chart. So 40 and 40 by 3 less than or equal to line. less than means towards origin. And next is 824 less than or equal to sign, it is towards origin. So the points, corner points are initial solutions. A, A, B, C, D. Four corner points which are present in the solution. So what are the corner points? A is 0, 0. B is oh sorry. Another constraint is there which satisfies, which has given x1 plus x2 less than or equal to 10. So that will come here 10, here 10. So that constraint will come here. Equation 3. So the area which is below that three constraints is feasible area, and not this one is not B. Now this is B, C, this is D. Sorry for that. So B value is 0, 40 by 3, and C is 0, 10. C is 7, 3. D is 0, 8, 0. So ZA equal to 0, ZB equal to 50, ZC equal to 29, ZD equal to 16. So optimal solution is B, right? So that is a way how to solve. Simple method. Question number 29, page number 108, gate 2004. A company produces two toys P and Q. Okay, production time of Q is equal to twice that of production time of P. T is nothing but production time. For example, whatever he has given in data problem we will write. And the company has maximum of 2000 units per day. So P plus Q, maximum of 2000. To supply raw material is just sufficient to produce 1500 toys per day. The supply of raw material is just enough to produce 500 toys per day. Okay, number of toys is equal to 1500 max. The type Q requires an electric switch which is available at 600 pieces per day only. So Q is less than or equal to 600, another condition. The company makes profit of 3 rupees and 5 rupees on P and Q respectively, maximization profit daily products. So first profits, for profits P on P it is 3, on Q it is 5. So maximize 3P plus 5Q subject to constraints. So whatever he has given constraints, time constraint, subject to p plus 2q less than or equal to 2000, p is less than or equal to 1500, q is less than or equal to 600. Why we have taken 2q means the production time is, it is taking for 1 unit of p you can produce 2 units of q, that's why. So of simplifying graphical method, p q, he has given q less than 600, p less than 1500, p plus 2q, what are the intercepts? P by 2000 plus q by 1000 less than or equal to 1. So p by 2000, q by 1000. This line will come here, 1, 2, 3. So the one line is this, 2 is this, 3 is, sorry, 1 is this, 2 is 1500, 3 is this one. So next, what is the feasible region? This is any, is there any greater than or equal to constraint? No, all are less than or equal to constraint. This is a feasible region. At each coordinate point, calculate the Z max. Z max is, there are points like A, B, C and D. A is nothing but 0, comma 0, B is 0, comma 1000, C is intersection of this point 600, comma 800, D is 600, comma 0. So calculate ZA equal to 0, ZB is equal to 3 of 0 plus Q, how much is 5 of 1000 is equal to 5000. ZC is 3 of 600 plus 5 of 800. So it is 3 of 600, 5 of 800, Q point and P point. Small correction here, P is less than 1500, not 600. So here x-axis is 1500. P is less than 1500. Why the 2 equation? It is not 2 equation, it is 2 equation. This one is equation 3. So what to do? Okay. If you substitute the values of O, sorry, A, B, C, D, E, you will get maximum 5750. So that point is called solution, and objective function is maximization of objective function is the value of maximization is 5750 and the point is